All right, home stretch. We now have to talk about the Pythagorean identities. So I'm going to start by explaining why this first one is true. And it's going to go back to the unit circle. So when we have the unit circle, we know that it has, from the center of the circle all the way to the edge of the circle, the radius is 1, right? So if I have, let's say, a unit circle, and I move it, right? And let's say that has a, that has a radius of 1. Okay, then here's what I know. From this point all the way to any point on the circle, right? It doesn't matter what it is. X comma y. The hypotenuse the radius has to be 1. aka if I think about this as a triangle, the hypotenuse should be 1. And if I think about this as a triangle, I know that this part down here represents the x value, and this part over here represents the y value. So I could take this and I could say that x squared, actually, you know what? No. It's always x first. Y squared plus x squared. All right, that one's on me. That's not on the Chromebook being bad. I'm just bad at writing right now. X squared should equal 1 squared, right? There's a Pythagorean part because that's the Pythagorean identity. I'm taking the legs of my right triangle, I square them, and I add them, and that should equal the hypotenuse squared. However, when we talk about the unit circle, we don't typically use x and y's. We talk about sine and cosine. So x is cosine of theta, and y is sine of theta. And going back to what we were doing last week, if I talk about y squared, well, y squared is just sine of theta squared, which I can express as a sine squared of whatever theta is, plus cosine deals with the x, so this is actually cosine of theta squared. So I get cosine squared of theta. Man, look at those beautiful 2's. 1 squared is just 1. And that's how that identity is formed. That's why it's true. It's just taking the idea that all the triangles that are within the unit circle are right triangles, and they therefore we can apply the Pythagorean theorem to them to make them true. Okay? So if I have that first one, I can use this first identity of sine squared of theta plus cosine squared of theta equals 1 to produce the other 2 iterations of the Pythagorean identities, right? Because they're all saying the same thing just from a different perspective. And here we go. Okay. So now if you notice, this next one is talking about 1 plus tangent squared has to equal a secant squared. Okay, so I'm going to take that and I'm trying to see how what I have right now can lead me to 1 plus tangent squared That's on me. That's on the computer. I recognize it this time. Equals secant squared of an angle. Okay, so I don't see much of a connection, but I know that tangent is sine divided by cosine. And if it's a tangent squared, that means it's a sine squared and a cosine squared. All right, if I see secant, I know that's 1 over cosine, right? But because it's squared, that means it's 1 over cosine squared. Technically, the 1 is being squared as well, but 1 squared is just 1. Okay. So, okay. I see the sine and I see the 1 because they are this numerator and this numerator respectively. I just have to figure out how this 1 would come from this cosine. And so here's what ends up happening. If you guys want to take a second, pause the video, so you can figure out how sine squared plus cosine squared equals 1 can be rewritten to produce 1 plus tangent squared equals secant squared. Take a second, pause the video, otherwise see what happens. I could take all of this, every single one of these terms, and divide it by a cosine squared of theta. All right, because if I divide everything here by a cosine squared, sine divided by cosine, sine divided by cosine would give me a tangent, but because they're both squared, that's a tangent squared of theta. Cosine divided by cosine is just 1, so plus equals 1 divided by cosine is secant. That's the reciprocal identity. So that's how I got that for secant squared. Okay. So that's how we derive the second iteration of the Pythagorean identity. I just took this equation here and I just divided all by cosine squared. So if I take sine squared of theta plus cosine squared of theta equals 1. If this is what I got from dividing by a cosine squared, then let's divide it all by a sine squared of theta, right? So sine squared divided by sine squared will give me a 1 plus cosine square divided by tangent square. Cosine squared divided by sine squared should give me a cotangent squared equals, and 1 divided by sine squared should give me a cosecant squared of theta, right? And right now, what I was doing, I was just able to prove mathematically why, if this is true, then this would also be true. And once I know that these are true statements, you are able to manipulate these, add, subtract, multiply, divide by whatever you want to write another equivalent form. And that is all verifying trig identities is about. It's all about the manipulation of these true statements.